Okay, so 4.2 graphing linear equations. All right, so the first thing I want us to make sure that we understand, you are going to tell whether a point is a solution. So tell whether the point 4, comma, negative 1/2 is a solution of x plus 2y equals 5. Okay, solutions, just so that you kind of understand what this is talking about. Solutions are everything we've been putting in tables, because these now have two unknowns. You don't know an x and you don't know a y. So we can't solve these like we did earlier this year, where we just subtracted from both sides and then we divided, because there's millions of answers for these, because there's two things we don't know. So every time that you guys are setting up these little tables, you're coming up with all types of solutions. That's what you're doing. Every time you go to a graph and you graph it, you are representing all of the answers with a picture. Okay? So, but you can't represent every answer in the world because there's millions of them. So what this is saying is basically they're saying, would this point be a point that would show up in your table? Okay? Or would it be a point on a graph? And if it would lie on the line, you'd say yes, it's a solution. If it lies somewhere off here, then you'd say no, it's not a solution. But let's say that we want to be lazy and we don't want to have to draw a full graph. We can just plug these points in and figure out if it works. So remember, this is your x and this is your y whenever you have an ordered pair. So I'm going to plug the 4 in for x right here. So I'm going to plug this in, make that 4 plus 2 times my y term, which is negative 1/2. And my question is, does that equal 5? If it does equal 5, it's a solution. If it doesn't equal 5, it's not a solution. Okay, so I'm going to start with 4 plus 2 times negative 1/2 would be negative 1. Well, 4 plus negative 1 is 3. That does not equal 5, so no, this is not a solution. Okay, so this would mean if I was to draw this graph, say this point would be located 1, 2, 3, 4, would be located like here, and it would not be on that line. Does that make sense? Okay, last hour I had a little bit of trouble with that, so if that doesn't make sense, ask me so I can help. All right, so pretty much exactly like what we've been doing, we're going to still be graphing equations. So graph the equation negative 2x plus y equals negative 3. Kind of what they do in 4.2 is they kind of expect you to get better at this. They no longer are going to give you the domain. So now they're just going to say, hey, graph it, people. And you're going to have to know what to do, which means you're going to have to come up with your own domain, your own table, and then you're going to have to graph it. Okay? So I'm still going to start off and make a little table. Okay, and domains are going to change depending on what you're using the problem for, but a good rule of thumb that works about 90% of the time is to use -2 through +2. Okay, that, like I said, 90% of the time that's going to be a good one. I'm going to show you later on reasons why you'd want to use other domains, but this is a pretty good one. All right, now I'm going to plug each of these in, and then I'm going to solve. But what do I need to do to this first? What would be helpful?
The y, like where the y is first.
Very good. Put it where the y is first, so that function form. So to do that, we're going to add 2x to both sides. So I get y equals 2x minus 3. Now, by rewriting that equation, it makes it way easier to plug in these values. So now I can plug in -2 right here and do 2 times -2 minus 3. So that would be -4 minus 3 would be -7. Then I would plug in -1. So So 2 times negative 1 minus 3. 2 times negative 1 would be negative 2 minus 3, negative 5. 0 is always easy. 2 times 0 is 0. Minus 3 is negative 3. Are we seeing a pattern emerging? What's happening? Adding 2. Where's that coming from in our equation? Here's our equation, right? Where's that coming from? The 2x, right? So that's not a coincidence. That's happening because it's times 2. So if I increase by 2 again, I get negative 1. Increase by 2 again, I get a positive 1. All right, so I'm going to go and I'm going to graph those 5 points. And by the way, not always can you get all 5 points on a graph. So kind of the rule of thumb is if you can get at least 3 of them, that's good enough. So graph your points. And we're going to make sure that we draw in our line because now we're graphing a line. And I want to put arrows on both ends because these lines go on forever. I graphed a very small part of this line. All right. Oh, I'm sorry. Yes, Faith.
So for our domain, we can always just put negative 2 to positive 2.
I said it works about 90% of the time. You're gonna see as we do more and more equations, we're gonna change this up, and I'm gonna teach you when to use different ones. But for right now, yeah, this works most of the time. It's a pretty good one to use. All right. So now there's gonna be some special types of lines that we need to go over. And all right, so we're going to graph y equals 2, and then we're going to graph x equals negative 1. So go ahead and draw yourself. You don't need a huge graph. X and y axis. Okay, so these are special types. Notice they're not set up like our other ones. It's missing, like this first one's missing an x altogether. It just says y equals 2. So I want you to think about the reason why this is going to work. So imagine that I have my table set up over here. And imagine I use negative 2 through positive 2. But this says that y equals 2. That means every single y is 2. So this y is 2, this y is 2, this y is 2, this y is 2, this y is 2. Every single y has to be 2. Now go ahead and start to graph that and see what happens. What are you guys noticing? Nothing? Nada? What are you guys noticing? Sam?
Along a straight line.
Well, technically, aren't these all straight lines?
Right, but
What type of line is this?
horizontal.
Horizontal, very good. Okay, we have not looked at any horizontal lines yet. Okay, where does this horizontal line, or what axis does this horizontal line cross? Crosses the y-axis. And where does it cross the y-axis at? 2. So do you see that why that is the equation? Y equals 2. It is crossing the y-axis at 2. All of the y's are 2. Okay? So what do you guys think is going to happen with the second one? So what type of line is that? What's it going to look like? Austin?
Will it be vertical across X?
Okay, very good. So it's going to be vertical. It's going to cross through this is your x-axis. This is at -1. Okay, because what this means is if I had a table, all of the x's have to be -1. So every time I go over -1 and I might go up, or I go over -1 and I might go down, or I might go over -1 and go nowhere, but they're all going to line up here. And that would be anything that's just an x equal. So those are very special lines that come up too. Okay? Any questions about any of that we just went over? No?